Hi, I'm Professor Andrew. Welcome to class. Today we're going to talk about why the sum of an even and an odd number is odd. So let me show you what I mean by this, right? So let's think of an even number, right? So let's say 6. 6 is an even number, right? But what if we add it with an odd number like 7? 6 plus 7, that's 13. And notice how 13 is an odd number. Now, the cool thing about this is that you can add any even or any odd number together, and you will always get an odd number. 1 and 2, 3, odd. 2 and 5, 7, that's also odd. But how do we prove that the sum of any two numbers that are even and odd will be, in fact, odd? Well, there's a little way that's pretty cool in here. Let me show you this. So you can actually define an even number. Here's how. So 2m, we'll say m belongs to the set of integers. So I'm talking like 0 or negative, 0, 1, 2, or negative 1 and 2. Basically integers, whole numbers, right? So m belongs to the set of integers. And in math we say that's z, the set of integers. Okay, so what we're saying here is 2 times any integer will yield you an even number. And that makes sense because, any number multiplied by 2 will be an even number, right? Now, how do we define an odd number? Well, you can think about it like this, right? Every even number, everything that's 1 after an even number is an odd number, right? So, for example, 2 is an even number, 1 after 2 is odd, and then 1 after 3 is even, and then 1 after 4, which is even, is odd. So you see how it's alternating even, odd, and it's always off by 1. So what we can do is simply add 1 to our even definition to get the definition of an odd number. Okay, so here's how that would look. You can say 2n plus 1, right? So we're just saying the same thing, but we're just adding 1, and then where n belongs to the set, once again, of integers, whole numbers. Okay, so let's actually find out how the sum of the two will yield you an odd number. It's quite simple. Let's say x, some number, is equal to an even number. Let's say x is an even number, so it's equal to 2m, where m belongs to the set of whole numbers, integers, while y is an odd number. It belongs to 2n plus 1, n, of course, belonging to the set of whole numbers. How do we find the sum? Very simple, right? You just add the two numbers. So it's x plus y. You can see that, good. Okay, so the sum of two numbers, right? And we just need to add the two together. So that's going to be 2m plus 2n plus 1, right? So this is x over here. It's the even number. And this is y, the odd number, 2n plus 1. And what do we get when we sum this? Well, you'll notice how we get, right? 2m plus 2n plus 1, right? See that? So, okay, I'm going to erase the board. It's a little crowded right now. But because we have that sum, right, I'll write it again over here, 2m plus 2n plus 1. Notice something really cool happening. We can factor out the 2. And why do we want to do that? You'll see. So you do 2, and then m plus n plus 1. And you'll notice this is identical, right? This is just distributive property. 2m plus 2n plus 1. That's equal to that, right? So they're identical. Why does this matter? M plus n, remember, m was an integer, n was also an integer. You add two integers together, that's still an integer, right? So you can say that m plus n still belongs to a whole number, right? So this still belongs to the set of whole numbers, integers. And notice now, we have the definition of an odd number. 2m plus 1, or 2 times any integer plus 1. That's by definition, remember, of an odd number. So that's how you prove why the sum of even and an odd number is odd. Thank you for attending my lecture. Goodbye.